Hello and welcome to the channel. Today we'll be doing a marginal analysis problem involving business economics, financial calculus using Mathematica. Alright, so we have a multi-part question here, about 12 parts it shows. It's basically given us a price-demand equation and a cost function. The price-demand equation is x equals 8,000 minus 20p, cost function is c of x equals 60,000 plus 50x, where x is the number of saws that can be sold at a price of p per saw, and c of x is the total in dollars of producing x saws. Complete parts A through I below. Okay, so first thing first, they want it expressed in p equals. So here's what you do for this. You can use the function reduce. X equals, remember. If one equals would define the variable you want to set up an equality or inequality. So just like this, reduce it in terms of p, and you have your answer. P equals 400 minus x over 20, and the answer is correct. Now they're asking determine. Here, I'll take a screenshot so that you can know what I'm talking about. Determine the domain of the function, select the correct choice, and fill in the answer boxes within your choice. Here's what you can do for this one. You can use the solve function, or it can be the reduce. Both would work. Take your function here, and you know that this function, which is the price, has to be equal or bigger than, you know that x has to be equal or bigger than 0. It's just how the math is. So you set up an equality. Instead of equals equals, you're going to do the bigger than or equal to 0 by pressing shift period and equals and then 0 and then x. Okay, so it didn't work because they want us to use the reduce. Okay, so this is the correct answer. It's gonna be A. So it's A 0 x 1000. Let's check if it's correct. And it is indeed correct. Here's the answer if you see it in the video. Okay, and now they want us to find the marginal cost. Find the marginal cost. The marginal cost is, so the marginal cost is basically the derivative of the cost function. We know that our cost function is 60,000 plus 50x, so we do d, which is derivative, 60,000 plus 50x for x, and that should be the marginal cost, 50, and it says that it's correct. And now they want us to find the revenue function and state its domain. So the revenue function is this, r of x equals x times p. That being said, let's go grab our p equals, which is 400 minus x here, and then put this whole thing between parentheses and multiply it by x. You basically get this, which is pretty straightforward. Record it just like this, minus x over 20, and then 1x outside parentheses. And it says that the answer is correct. Now they want the domain for this function, which shouldn't be a big deal. We'll do the same exact thing as we did earlier. We're going to say, actually, instead of solve, we know that we should use reduce. And then we're going to take this function, as in this function, and we know that it needs to be bigger or equal to 0. So let's set up our inequality for x reduce. So it seems like the answer is either C or D. I think it's C. I'm gonna try my luck with C. I believe this is the one. Yep, it is the correct answer. Typed up just like this. And now they want us to find the marginal revenue. So the marginal revenue is just going to be D of this guy, which is our revenue function here. And this here should be the answer, 400 minus x over 10. Yep, that's correct. And now for E, they want us to find R, the derivative in R prime of 1500, R prime of 4500, and interpret these quantities. So let's do just that. We know that this is our R prime, or the derivative of the revenue. So first we can do x, replace all x for 1500. Of course, there's different ways of doing this, but this is the way I'm doing it. You can always have your function defined and manipulate it that way, but I just decided to go this way. Replace x. So the answer is, let's see the options. Find and interpret R, select the correct choice. So R prime of 1500 equals at a revenue of Versa. I think it's D. So R prime of 1500 equals 250 as we saw. And then at a production level of 4500, because X is the amount of saws being produced, revenue is decreasing, since you saw that it's a negative number we got, decreasing at minus 50 per saw. But since it already says decreasing, just type in 50. Oh, it says it's wrong. Substitute the given value into the marginal revenue equation, simplify. Marginal revenue is the instantaneous rate of change. Okay, well, this should work. Isn't this my revenue function? Yeah. Huh. Okay, so I guess it's not this one. Now let's try. This is curious. Revenue increasing at a rate. Could it be C? So 1500 to 50 at a revenue of dollars per saw. A revenue of per saw. Saw production is decreasing at a rate of this doesn't make sense to me. wonder why. I'm not sure what they want. At a saw production is increasing at a rate of, and it's decreasing at a rate of, revenue is decreasing at a rate of 50%. That's what I would say. At a production level of 45, revenue is decreasing at, is it 250 minus 50, so 200? Correct answer was B, and this is what they have wanted in the spaces. So 250, as I had said, and then at a production level of 1500, revenue is increasing at 250. Okay, alright, so they threw me off with the R prime of 4500. Actually, they didn't really throw me off with it because it just came up here, but I guess I was trying to mix both of them in one. Okay, so for this one here, I know what to do, and it's gonna be the one that is decreasing at a rate per saw. Decreasing at a rate per saw, so it's gonna be B as well. So B 4500 equals minus 50. At a production level of 4500, revenue is decreasing at a rate of $50 per saw. And this was correct. And I had that line of thinking. So this is the correct answer for this one. And now they want us to graph the cost function and the revenue function on the same coordinate system for find the break-even points and indicate the region of loss and profit. My plotting skills are not that advanced with Mathematica, but we will try to plot them. Here's the plots anyways, if you'd like to see them. So, graph the cost function. Okay, let's start with the cost function. Where was it? Uh, this is the cost function. Alright, so that's the one line. And now let's plot the other one. Oh, actually, hold on. It's 5,000, right? Yeah, 60,000, so it's not this, it's this. Okay, didn't change much. And now they want us to plot the R of X, the revenue function, which is this guy. X from 0 to 8,000. Alright, so this here tells me that it is going to be, okay, use light shading for regions of profit and dark shading for regions of loss. Find the break-even points. Alright, so just by looking at it, we can rule out A and B because the cost plot is not correct. And then between C and D, they want light shading for region of profit and dark shading for region of loss. So profit is light shading, so I believe it's going to be C. Yep, it was indeed C. Perfect. I think there's still a few more parts left in this very long question. Find the profit function in terms of x. P of x. Why? How did we find it the other time? So the profit function is cost minus revenue. So we know our cost revenue, which is this guy. Put it between parentheses and subtract from it. And we subtract from it. We set the R of x, which is this guy. And it gives you this. Simplify it. Expand, simplify, does the same thing. Let's see what full simplify would do. We'll do this. However, I believe that this here should do it. Let's see the traditional form of it. Yeah, let's try it. Minus 350x plus 6000. It says it's wrong because it's R of x minus C of x. Oh my god, silly me. I swapped them around, so it's R of x, which is this, minus. I guess that could be one of the benefits of defining your functions, because then you could just say R of x minus C of x. So this here is the correct answer. The rest is garbage. Let's delete it. With this one, can we simplify? Or expand, would give you the same thing. Or factor, which would give you this. I'm going to stick with either the simplified or the expanded form, but the traditional form, which gives you negative x squared over 20 plus 350x minus 60,000. And this time the answer is correct. Now they want the marginal profit. So marginal anything is just the derivative of it. So we're going to do d of, take our profit function, which is this. So the answer is 350 minus x over 10, which gives you the correct answer. And one last part left, which is this. And this here is the marginal profit one, in case you want to have it. Yeah. So now, what do they want? Find P of 1500. Okay, so we'll take our derivative, our prime, P prime, which is basically this. And then we're going to do 1500 in this case. And let's interpret it. So P prime of 1500 at a production level of 1500 saw profit increasing at a rate of 200%. I believe it's A. So P prime of 15 is 200 at a production level of 1500. Sauce profit is increasing at a rate of 200%. Check answer, and the answer is correct. So it is A. There's a snippet. And now for the other part, which is this here, the one I'm concerned with, the P prime of 3000. we'll do the same thing, only we'll change this to 3,000. You get 50. So, same thing. This one's actually going to be B, profit level increasing at the rate. No, production level, so it would be D. Okay, so first 50, then at a production level of 3,000, profit is increasing at a rate of $50 per saw. And the answer is correct, and this concludes our video. Thank you.